homework today?
Chat, does Sturger not look like Superman? Does he not look like Superman?
Hey, if you were not here Friday, you can come up here and grab some glasses.
Sturger, take the glasses
If you're not here Friday, you can get some glasses.
Sturger, take your glasses off.
Oh.
Why not?
For notes, that's all.
I'm going to take your shirt off.
If you were here Friday, you can get some glasses.
That's why I like to avoid the conversation.
Pleasure seeing you, joint.
That's how I felt too. Sturger, you're my superhero right now. I need you to you're my hero. I need you to take your glasses off.
I'm on.
I understand
Sturger, I figured it out. Remember that time you hit me? And you said, ow, and I said, how that hurt? And you said, you're made out of bones? I figured out you're the man of steel. You don't have bones, you're made out of steel. And actually, Sturger, Stu, your do actually fits yourself. Your haircut actually fits you. Is that you say?
Your socks on? Yeah. The homework that was due last week. I forgot to put it on in. It was done.
Probably most of your time.
I don't even
Jack, I don't know if we're having a... You guys. They need me to work. Everyone that works at
It's a parachute. Wait, when did you
Alright. Okay. Alright. Now, hey. Now, the reason why we're seeing these weird little pods, what we talked about Friday was we talked about how to graph polynomials, right? How to graph a polynomial like X Intercepts, where the Y-Intercepts are, how to find, is it symmetric, is it not? The goal today is to kind of continue the same idea. But the goal today was to look at challenging questions. Not like relatively easy ones like we did on Thursday, Friday, but to look at ones that you will need to take some serious thought into it. Now, I'm hoping that you look at it and go, it's not hard. I'm hoping that you think that it's easy right when you first see it. I have no idea where you're going to be. So we're going to start with there, and we're going to move on, okay? All right, so let's start with the first ones here. I'm just going to pick a problem from the book, so this could be or not be an actual homework problem. I have no idea. All right. So again, we're on section 2.3. This is the last day of 2.3 that we'll take notes, like rear notes on. And again, what we've been doing is graphing polynomials. Now, the big idea today is knowing what a polynomial is. We're going to start with that. The reason why we've discussed the last couple of days, like how to graph, rough sketches. But why do they always turn out a certain way that they do is the big deal. That comes back to the definition. Okay? Once we're through that, then what we're going to discuss, we'll discuss the leading coefficient test. And what that tells us end behavior, like where the tails are going. That's the leading coefficient test. So if you look at the book and they ask for end behavior, you know what they're talking about. The next thing we're going to discuss, number 2, we'll discuss X Intercepts. This one, for some reason, always takes the most work. Why? Why does this one take the most? You have to factor. And factoring sucks. It just takes forever to do it. Okay? All right. Line number 3. Third step, this is one of the easy parts. Y-intercepts. We talked about that Friday. It's just super easy. You should know what your Y-intercept is first. Today, I'm going to give you a problem where it's not easy. Where you actually have to spend some time thinking about it. What a Y-intercept is. Step 4. We talked about the symmetry test. Is it symmetric or not? We've discussed symmetry tests since chapter 1, so you should know like a rough idea of how to do that where it's substituted. And the fifth final check that we did, turning point test. How many times will it turn? And we really discussed like Friday. Friday was the first day I introduced what happens when it doesn't turn as many times as you thought it should. And that was the idea that we discussed Friday. Hopefully that video will be online today. It's taking a while for Google to upload those. I have no idea why. All right, but that's kind of our goal today. Once we're through notes, we're done for the day. That's all I want to do. Just do some easy notes. Tomorrow we might get some homework on it, but it's something that I think you should be able to do. Okay. No. All right. After Thanksgiving break. All right. We good with this so far? All right. Let's move on. Let's talk about polynomials. Now, I'm just going to discuss it with this graph. Polynomials, they can be any variables. You know, the big idea here about a polynomial. Okay, whatever these are. I'm just going to pick a random polynomial. No. They always give you some name of the polynomial. It's got some variable in it, so it's got x's, right? The big idea that the book talks about for polynomials, any numbers and letters using basic operations combined using numbers and letters and stuff. But the big idea was these powers had to be whole numbers. That's something that I don't think I've ever discussed with you. To make it a polynomial, you can't use negatives. Okay, so if I suddenly on one of these problems have a negative power, it's not a polynomial anymore. Or if one of these items suddenly has a fraction in the power, now it's not a polynomial either. Okay, can't have fractions, can't have negatives. Okay, that's just a big deal. The reason why is it would make really sharp corners. Okay, so if you were to look at graphs of these objects, what would happen? You'd have these really defined like pinpoint areas where it comes down to a single point. It's called the sharp edge. That's what they call it. And that's not a polynomial function. Polynomials are very smooth and continuous as they go from left to right. That's why when we've been graphing these since last Thursday, you notice every graph I've been doing had very nice, easy up and down motions, right? It's been fluid as they go left to right. There's no breaks in the graph. It's actually continuous. And that's just the reason why it works out that way is because of this situation. You can't have that. You can't have these powers. And the book does a really nice job of kind of showing you that. It just, we haven't discussed it yet because we never had to deal with that. Is it a function or not? Is it a polynomial or not? Okay. Questions on this idea of like what a polynomial is and why I'm drawing them certain ways? Why it's curved, why it's smooth. I don't know if anyone really asked a question yet, but I could definitely sense that there was some question like, why do I know a certain graph goes a certain way? Because it can't be this. So, okay. Let's start with an example. I'm just going to pick one from the book. It could be a homework problem, it could not be. I'm just going to pick one. Let's go with x cubed. X plus 2 squared. X plus 1. That might be an x minus 1. No, it's x plus 1. Alright, so here's my function. So this is my function that we're going to draw. Now, why does this look goofy? What's wrong with this? Not distributed. Okay. What else did we say over here? Oh, okay. It's not distributed, number one. It's already factored apart. That's weird. Like usually we have to do this later. Like this is like where we have to get to in line number 2. They've already factored it. So I can already tell you right now where my X intercepts are. Because the way that they've already broke up all these parentheses. So that's a nice thing. Some of the problems are already factored apart. The problem is I don't know the leading coefficient test. I don't know it. Because I don't know what that first number is. So I'm going to have to FOIL it out. And I don't know where the Y-intercept is. That's the problem. So that's where we have to really trust in our definition of what a Y-intercept is. Does that make sense? I'm going to try to show you some shortcuts today. So you don't have to do like a billion times harder work than you need to. Okay, but let's start with, I know this seems like I'm going out of order. I'm going to start with the X-intercepts on this problem. The reason why is like Jack, like you said, it's already put apart. We have to foil it together, right? So it's already pulled. So what are my X-intercepts that would make each of these things equal 0? 0, -2, 4, or -1. Okay, we go to those as my X-intercepts. Now I want to put the dots on those locations. So there's a dot at 0, there's a dot at -2, there's a dot at -1. And the problem is I don't know where the tails are going yet because we haven't done the leading coefficient test. Now, the good news about this, what I can tell you, is it going to bounce or pass through those numbers? Because they've already factored it. So what I have to do is I have to look at the power. What was the power on this first item? 3. That's an odd number. That means I'm going to pass through 0. Since it's an odd number. It passes through 0, whatever the graph's going to be. Okay, what about this one? What's the power of this parenthesis? Even. That means I'm going to bounce off of this number. And then the last one, it's a 1, so it's an odd number, so I will pass through like I heard. Okay, does that make sense? Like, how do I know what's going to happen at each of these X-intercepts? Either passes through them, or it bounces off of that number depending on the power is in the parentheses, or the variable. Okay, so now that I know that, I've got my X-intercepts, I know what's going to happen. The problem is I don't know where these things are going to be going and whatnot, so I have no idea. So I got to figure out the end behavior stuff with the leading coefficient. I'm going to try to teach you the shortcut for doing this. The shortcut for actually figuring out what the leading coefficient is looking at what's out front of each of these items. So what's the number out front? They're all 1s. It's all positive, correct? So now at some point, it will be positive. That's what I know by actually multiplying these all out eventually. The number out front will be a 1. That's just what I can tell you. So the leading coefficient test. I know that just common sense, I'm going to have a 1 up front. Because that's looking at each of the items from the X-intercepts separated by themselves. They're all 1s out front. So when I actually FOIL this out, there will be a 1 still sitting there. What was the power on this item? 3. What's the power on this item if I were to actually FOIL it, though? There would actually be a 2 there, like an x squared if I actually FOIL this parenthesis by itself. So that's x cubed, x squared, so I'm up to x to the 5th now. And what's the power on this one? 1. So x to the 3rd, x squared, technically, and x to the 1 makes x to the 6th. How I'm doing that is I'm combining all the items as I go through all the variables to make the largest item, and this power affects it. That's how I know it. That'll be my biggest term. Even if I FOIL this thing out, that's what my biggest term will be, and I'll guarantee I will do all that math for you so you can see that. But does everyone see what I'm doing there? Okay. All right, now to prove my point, I am going to FOIL that all out. This is what it actually means. So FOILing this out, that's x squared plus 4x plus 4 times the x plus 1. I'm going to FOIL that out. That's x to the 3rd, 1x squared plus 4x squared plus 4x, 4x, 4, and I'm taking everything here times x to the 3rd. And so this will turn out to be x to the 6th, like I just said. And then x to the 5th, and 4x to the 5th, and 4x to the 4th, 4x to the 4th, and 4x to the 3rd. Make sense? So that's pointing everything out first ever and last, distributing everything, and I can combine like terms. But this is the biggest item. So, even or odd power? Even, so that means the tails are going the same direction with end behaviors. Tails are either going up or down. And what's the number up front? Positive. So that means they're going up to positive infinity. since the tail's going the same direction. So I know my tail's up here going the same direction. So I can already start getting a view of what's happening here. Okay, questions, comments on what I just did there?
Yeah, how did you find the 6 by doing that over there? You had them all together?
Yeah, I'm putting basically this variable. This one here is technically an x squared. And this variable is x to the first, so it's x to the first, x squared, x cubed. That makes 3, 5, 6. 6 x's. And then just knowing what the numbers are up front, I can multiply those together. Then it was going to be a 1. That's just like my shortcut. I can just tell you right when I first look at it what it's going to be. Okay, questions. That was good.
So if you had a 2 in front of
Right here.
Yeah.
That would be, this would be technically a 4x squared. So then it would be a 4x squared times this would be 4x to the 5th, times this would be a 4x to the 6th. That, just kind of knowing what that would be, even if you want to FOIL it, you can do that. Okay, questions. These are good questions.
So it's the coefficient of the largest power.
Yes, that's the leading coefficient. That you have to look at the base power. That's the idea. That tell you where the tail's from. Outside tail. Good. Any other questions? That's a good thing. You got to figure these out as we go.
Are there going to be exponents of the same power? Like the largest could be 2 with the same power?
Then you can give mine. If they're the same powers,
Oh,
you can give mine.
I'm overthinking this for.
Yeah. That's good. These things we got to
I'm just
figure
trying to
out.
ask better questions.
That's Monday. Monday. All right. We good? Yeah. All right. Okay. All right. So let's keep going here. Y-intercept. The shortcut for the Y-intercept, the easiest way that I figured out how to do this, just like common sensing it, is just plug in 0 for all the x's. Because if it's a Y-intercept, it means 0 has to be the x number, right? Because then you're hitting the y-axis mark. So if I plug in zeros to all of these things, I can figure out the y-intercept is really fast. That's 0 times this number, which I don't care about, times that number, which I don't care about. And so what's 0 times anything? 0. Well, duh, I already told you what the y-intercept is. We already do the dot with the order. So that's the shortcut. Just plug in zeros to all these x's, and then just solve it. That's the shortcut. If it doesn't look normal. If you did it over there, like I FOIL it all out and plug zeros in for all the x's, you get 0 as well. So that's my y-intercept. So y-intercepts are straightforward. You just have to know the definition to plug in 0 for x's. So it's not granted to be easy, because maybe they don't have this term. So you actually have to plug in zeros. So that would be 2 squared, which is 4. This would be a 1, so 4 times 1 would be 4. And that's right at the y-axis. Okay, questions on y-intercepts? Symmetry. Now this is the tough one. On the symmetry test, we do have to actually FOIL it all out, which I did. That's why I actually FOILed that for you. And we're going to plug in the negative x's into this problem. Let me actually combine these. So that's x to the 6th. This is 5x to the 5th. This is 8x to the 4th. And a 4x to the 3rd. All right, so this is what we get when we actually simplify this problem. This is my function. To do that symmetry test, I have to plug in negative x's into every variable where they sit. Only the variables get the negative x's. And what I'm going to look at is what happens to all those variables. That's what I'm looking for. So right here, this thing will stay the same. So it'll be y x to the 6th. Now y don't stay the same. The power of 6 is even. Cancel the negative. This is the power of 5, so the negative will go to the outside. This thing, power of 4, cancel out the negative sign. And this thing, the odd power of the negative sign will stay there, so it'll be negative 4 to the 3rd. All right, now, is this the complete opposite of what we started with? No. Because the complete opposite would be negative, 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 negative. That'd be the complete opposite. Is it the same thing we started with? No. So it's definitely not symmetric. That's what I'm telling you right now. This thing is not symmetric. So it's neither. By just checking, like, did it turn out to be the original thing we started with, or was it the complete opposite? It's not symmetric. So that means the left or right side. Take rid of the New York here. All right. So it's definitely not symmetric as they go over the y-axis. I can kind of tell you that. The reason why? we hit some x-intercepts over here that we didn't hit over here, so it's probably not symmetric. So the left and right side of the y-axis will be different. All right. We already know the bouncing, passing through. I'm going to start drawing those here in a minute. Turning point test. What was my biggest power? 6. So I'm potentially turning directions 5 times. So I subtract 1. So it'll turn like up, down, up, down. It'll turn 5 times. So that's what we're going to try to count in the very, very end. That's a turning point test. You take the biggest power item and you subtract 1 off the power. So it's going to turn 5 times. Okay, but let's actually get a glimpse of where this thing's happening. So I'm going to pass through 0 at some point. I'm going to bounce off a -2. I will pass through -1. Okay, so bouncing off of -2, passing through -1, passing through 0. It's probably looking something like this. You know, it's a rough sketch what this thing's going to look like. And let's see if it did turn directions 5 times. So I'm going down. That's up. Down, up, so I turned directions 3 times, so makes sense. There's a couple double roots in there, like this thing, the 0 happened 3 times technically, this one happened twice technically, so that kind of made up for all the different numbers. I didn't have a bunch of different x-intercepts, so it makes sense that I didn't have to turn it all 5 times because I had a bunch of numbers that repeated over and over and over, like 0 repeated 3 times technically. You know, if I had a bunch of different x-intercepts, I could see it turning directions a bunch of times. So that makes sense. I only had 3 numbers as opposed to like 5 or 6 different x-intercepts. Okay, questions on the turning idea. The turning point is just a rough thing. That's why it's kind of a side note. You know, if you're turning 12 times and you did something wrong, the maximum amount of turns is 5. Does it have to turn 5 times? Just depends on how many x-intercepts you have. I only have 3.
Was there like some sort of method as to where you turn?
Yeah. I just drew and turned at some point and then went back down and turned again. I don't know where those peaks and valleys will be. That's something we'll get later in the section. That's right now. I just care about, are we hitting the right x-intercept, hitting the right y-intercept? Do we know where the tails are going eventually? That's all I care. The peaks and valleys we'll figure out later, like because these are relative minimums. That's actually an absolute minimum, and then this is a relative maximum. And it's smooth. It's supposed to be smooth because it's a polynomial. Okay, now I do want to graph this just so you can see it, and then we're going to try one by yourselves. Okay. All right. So let's graph this on a calculator. Now, again, what we talked about on Friday was that I know that you guys don't. Some of you don't have graphing calculators. I know you don't have your MacBooks anymore. But the good news is you still have Google, and you still have a Chromebook that can search the internet. So I'm going to pop up a Safari tab here. Alright, so here's Safari, the web browser. You can use Chrome, it doesn't really matter. If you just go to Google, you can type in your equation, it will graph it for you. Y equals, and then you just type it in. Right, it even shows you there. It'll actually graph it for you. Or if you go to Wolfram Alpha, which is one of my favorite things, Alpha, which is a Microsoft website, it's owned by Microsoft. It looks like a search engine. It's really not. What we talked about Friday is this is one of the world's most advanced calculating systems. Okay, this idea of Wolfram Alpha, it looks like search engine. It's not. Google. What Google does is it strips information from websites, and then shows you all the websites that have that data that you can search for. It scours the internet for every website known to man, right? So it gives you the top hits or the people that paid the most money to be on the top of the list, right? What Wolfram Alpha does is it just pulls information from their one server that they have. It's like an encyclopedia. That's what I think of it as. It's a book that has knowledge of it, and it just shows you the information that it has. So it's things that Microsoft has. Now, the best thing about this Wolfram Alpha, to me, it's just a calculator. That's what it is. Calculators do one thing. You type in something, it spits out answers. That's all it does. It doesn't scour the internet for it. And the idea is that this thing is using one of the most advanced calculators in the world called Mathematica, which is what all supercomputers use to find like digits of pi and irrational numbers and stuff, and primes. They use that program to find the next one because it's actually used in supercomputers, which is awesome. You can use it for free. So if you type in, so I'm going to type in my function. Now, You can type this function however you like. I'm going to type it the exact same way we saw it. X to the third, so I hit the shift 6 button to give me a little caret to the third, parenthesis, x plus 2, close parenthesis, caret, and that was what, the power of 2, and then parenthesis, x plus 1. Hit enter. And the best news is, it will actually figure out what that thing was. It figures out what that final item was, which is right here. That's what we said it was going to be. This is the expanded form, which I showed you over there, when I actually foiled it out. It shows you alternate forms where I can like change the numbers up and it's still the same. Because you can multiply any of these numbers by anything. So they multiply everything by -1, which is fine. Or they moved it around, solve for 0, that's standard form. So I love this program. And the best news is, it graphs it for you. Look at that. It shows you the graph. And it shows you exactly what was happening there. And this graph that it's going to show you will only show you where it's turning. So if it has like an end cap, you just have to assume it goes forever. So it's going to go this direction forever. It bounced off at 2, passed through -1, passed through 0, and kept going.
Is that graph technically 10 times?
Well, let's see. 1, 2, 3, and kind of 3. It's kind of leveled out. If it would have went down, yeah, but it was close. And do you agree that it looks somewhat like what we came up with? Roughly. That's the goal. Rough sketches. You get an idea where this thing's going. Alright. And it's free. Okay. Now, what I'm going to do, I'm going to give you one of these by yourself. I'm going to see what you can do now. Okay, now, but each of you will have your own little mission. So I'm going to give you a little card that will tell you what you need to find for that one problem. Okay, now we're going to rotate and see if you can find another piece. So you're only doing one part. You're not doing all, because that's too much. I'm going to have you do one part. Okay. All right. Let me erase all the stuff on the board and see if you guys can pay attention.
I'm taking notes and everything. So I can take that in.
See if you guys are paying attention. All right, here we go. So I'm going to give you one problem. Let's see how well you can handle it. And I'm going to give you guys all a mission here to do. So don't start right away. I'd just like you to write this down. All right, here we go. Okay, here's my function. Okay, I'm going to hand out some little cards here. You will only have one thing that you have to find. That's it. You will not have to do them all. So maybe you're only finding Y-Intercepts. Maybe you're doing X Intercepts. So you've got to figure out, and I'll give you the card that will tell you what you are doing.
We work on the
Here's what you guys do.
or on a piece of paper.
And you can put it on your notes. Okay?
Yeah, John, that's for you, bud.
You got it. You guys are doing these. And let's see. Have you guys yes. Jack, what did I just give you guys?
30 points.
Alright, you guys will be that's not bad. And let's go with I haven't picked your last group here. You guys look like you can handle X Intercepts.
We have to back it. Oh.
Everyone got a job, yes.
was gonna watch it last night, but then I decided on finding board. There's a site that's constantly updated in the Facebook. One of the most used sites with like publishers on there. 123movies.is. There's a couple others.
Yeah, it's gonna be pretty. What was your power?
Now we gotta compress it now.
Hey, you can set that window by hitting the window key, and it's that way you want it to go 8 to -10 to 10, 10 to 10, going up and down. You can use it for it. All right, so first and foremost, going in order, leading coefficient people. Who is my leading coefficient people? Okay. Was it easy to start with right away? Yes or no? No. Why not? Yeah. So, if you're listening to this, the leading coefficient people said it wasn't easy because they have to FOIL it. That sucks. So that FOILing, that takes a while. It does. Because you need to figure out what your greatest power is. Now, what was that shortcut I just taught you earlier? Yeah, x squared, the x, and the other x. What's the numbers out front of all the x's? 1. So what will be that when I multiply it all together? 1. What's your biggest power? X to the 4th. So, knowing that, where are my tails going? They're both going up because the positive, and they're both going in the same direction because of the 4. Okay, that's M Baber. So leading coefficient people, good work. X Intercept people, raise your hands. You guys had the easy job. That's a rare case. This is the easy job because it was already factored for you. So, can somebody give me what were the X Intercepts? 2, -4, and +1. Now, okay, so that was from the one group. That was good. The other group, X Intercepts. Am I going to balance or pass through those numbers? Tell me one at a time. Balance up 2? Okay, now why? Exactly. The x minus 2 parenthesis has 2 on it. That means we're going to bounce off of that number. Because the even power means you bounce off of it. It's always the opposite. So you always set them equal to 0 and you solve it. That's how it is. Okay, we're good with that so far. Okay, alright, so let's draw those dots. So we said 2, -4, and 1. Okay, and now I can get kind of a feel for where this thing's going. The problem is, I don't know where the Y-intercept is, which is a rare case. Who's my Y-intercept people? Where did we hit? Negative 16. Ooh. Negative 16 down the road. Now, what was the shortcut to figure that out? Put a 0 in for the x's. That's your shortcut. So if I plug a 0 in to all these x's, this is actually the easiest way to do it. 0 minus 1. We can actually figure out where my y-intercept would be. This would be negative 2 squared. This would be 4. And that'd be a negative 1. So this would be a 4, because if I square it, times 4 times a negative 1, and you're absolutely right, that will hit a negative 16. So now that I know that, I can start piecing these things together, and now I can actually draw a sketch of this. So my sketch is doing something like this. So I'm bouncing off the 2, passing through the other number. So I'm going to pass through this number, go down, probably hit 16, come back up, pass through that number, bounce off the 2, and it's gone. So it's looking something like that. Now, how many times should I turn? Turning point people. 3 times. Because why do we know that?
Because highest exponent
Minus 1. So let's count. This was 1, 2, 3. That's probably right. We turned 3 times. That's good? Good work? All right, and symmetry people, where are we at?
Nope.
Well, are you sure?
Not symmetry.
Okay, so not symmetry. All right. So for those who say not symmetry, all right. Why?
What?
Why? What do we have to do first?
Well, we blurred it out.
Okay, that's the rough part. If you didn't hear that,
Yeah.
for the leading coefficient people and the symmetry people, you have to FOIL. You have to get it out to that full expanded form. Because if you don't have it there, you can't plug in the negative x's, and you don't know what the leading number is up front, or the biggest power. So there is a way you have to have an expanded form at some point. Okay, so now if we FOIL this all together, I'm going to try to hopefully get to your answer as fast as I can. That's an x. Plus 4 times this. Jeez, that's tough. X third plus 4x squared minus 4x squared minus 16x plus 4x plus 16. And then all this times x minus 1. X to the 4th minus 1x to the 3rd plus 4x to the 3rd minus 4x squared plus 4x to the 3rd, sorry, minus 4x cubed plus 4x squared minus 16x squared plus 16x plus 4x squared minus 4x plus 16x minus 16. All right.
Yeah.
Holy crap.
Yep.
All right, so
Yeah, I do that in my sleep.
I thought for the leading coefficient we didn't actually.
you didn't, if you know the shortcut, you would. But on this, you have to. So now that we got to this, if I plug in negative x's here, that'll stay positive. That'll go positive, go negative, and as you can tell, what's happening here, it's not going to go every other. It's not. It's going to be. It's not going to be the same thing we started with. Because only certain items up here actually change, not all of them. So that's just something you need to realize. Yeah, this is going to be a nightmare of things, and this is probably what it looks like. So it's definitely not symmetric. And the other way to tell this not symmetric. Did I hit the same X intercepts over here? No. That's how I know it's not symmetric. They're hitting different numbers across the lag. All right. Okay, that's it for today. Very easy notes. Tomorrow, be ready to go. We'll do one more of these tomorrow, and I'll pick a kind of a tough problem, and then we'll see kind of where you're at.
Don't give us an assignment with Thanksgiving Award.
I think every week is gonna give us an assignment over Thanksgiving. Because we'll have time.
You get another sentences.
So it's
14
half hours up. How much Canada?
That's something else I can.
I would get off. I don't know what that
Or you can
But we swim in a river. We're like, if you go cross over in Canada, and on one side of the river.
That's awesome.
this is
My family's born and raised there.
Born and raised.
That's something we will eventually get to.
What is?
good job. Now
Are we getting to?
you
It's
made
like
me-
the point pointed.
you made me laugh.
John, no,
Yeah.
then nobody.
No,
It's beautiful.
it's due today. That is.
I know. But I just like you know, right? Always do.
But what has literally nobody
This
says
year, thanks for reminding me. Are you gonna be able to stay away from the movie?
On Friday night, I about fell asleep driving. It was scary.
Hey, how did you guys do it?
We won.
Not fan.
One is scrimmage.
According to Johnny, your time of performance. I was thinking.
I'm nervous.
Varsity A.
Oh, you guys had a varsity.
It was just like separated.
I wouldn't mind getting any mine.
We were almost right at half. He started trapping the second half. You're off by
Fletcher's Quizlet is word for word his test.
I'm like, it's like not. It basically is a study.
These classes study.
It